Alright guys, welcome back. In this video here, we're going to start discussing just the overall concept or what we're going to cover in this section 6.2. In the previous chapter, we introduced both indefinite and definite integrals. We looked at just a few application example of definite integrals. In this chapter, in this section here, 6.2, we're going to explore furthermore applications in business and economics that uses definite integral to solve those applications. So what we're going to cover in this lesson is it says three topics that we're going to cover. The first one is called probability density function. You probably heard this before in your stats class. We're not going to go over in details a lot about the background of this here. We're just going to introduce a definition and just discuss how does that relate to definite integral, and then we're going to solve example. We're going to keep things brief and not trying to talk about too much about it, and which may confuse you. And the second topic we're going to look at is continuous income streams application. Under this topic here, there's going to be two type of continuous income stream. We're going to have total income. Okay, and that's going to be pretty straightforward calculations. And then we're also going to have future value of a continuous income stream. Okay, so that will be the second topic. And lastly, the last topic will be discuss on consumers and producers surplus, and these topics are more familiar to many of you guys because you guys are a business major. I'm sure you guys discussed those topics in your econ class. And in this classes, we're trying to take those business concept and capture it, or just explain it using mathematical values or formulas or equations to make sense of it. So let's get to the first topic, probability density functions. So in certain scenario in real life, you have variables. You have you have things that just occur by chance or not by chance. And in the stats class, we discuss that more in detail, really. But in this class here, let me just go ahead and read the definition first, and we'll talk more about that afterwards. So it says that the probability density function is a function f. Okay, so is a function f with the variable x as independent variable, and usually x, we refer to x to as a continuous random variable. In the stats class, we talk about this as being a variable where it can take up any value within an interval. So here's some example. X may represent an IQ score or the height of a person in inches. Those type of variable, the value of those can be anything there. It's not a discrete or not a whole number. It can be a whole number as well. And it said here in certain situation, right? In some situation, we're able to define, or we're to find a formula, a function f, that used to determine the probability of x occur within an interval c to d. Okay. In order for us to use that function that we found as a probability density function, it must satisfy these three conditions. The function itself, the value has to be greater than or equal to 0 for all x. The area under the curve of the graph of x is exactly 1 from negative infinity to positive infinity, and the probability of x between c and d is equal to the definite integral of that density function from c to d. So that's a lot of formal stuff there. I mean, all this just to establish some sort of formality, make sure that we have what we need in order for us to establish something is considered to be a probability density functions. In terms of picture, what what this three condition really saying is that we have a function, okay, in terms of graph, and that function f there could be look like this here, some sort of bell-shaped curve, and the total area equal to 1 underneath the curve. Okay, all right, and f of x is greater or equal to 0. Okay, so this is your curve here, f of x. That's the density probability functions. And the last condition is saying that, you know, if we have the area between two values, c and d, let's call it c here, d there, okay, all right, then this area here, this area, right, is the same thing as the definite integral from c to d, f of x dx, but this area has a meaning, not, you know, just an area, but it's referring to the probability. So this now, you know, this is equal to, if we want to interpret this, equal to the, you know, probability, or the probability, the probability of the outcome of x in the interval c to d. Okay, all right. So in the stats class, we use a z-score table, t-score table to look up the area to the left of the curve, to the right of the curve. All those numbers were generated or were estimated using definite integral, and you know, we didn't quite discuss that in stats class, but we just kind of read the numbers off the table there. So that's just, you know, a brief introduction of what is a probability density function. Is a function describe the probability of a certain event occur using the variable x to involve continuous random variable, and we're trying to show, okay, well, how does this event occur between this value to that value, and we connect that to the definite integral concept that we studied in previous chapter. Okay, so with that being said, let's get to our first example. Okay, this example here, we have a function that describes a continuous random variable. So t in this case is our continuous random variable. Okay, so that's t, and t stand for what? T stand for the length, right? The length of a telephone call in minutes. So that's our t. And f of t is a formula that being able to describe the chance of the probability, how long, you know, a telephone call is lasted between certain minutes. Okay, as I said it earlier, some situation we were able to find this function f of x here, or in this case f of t. So a function f of t is set up as a piecewise function to make sure that it is continuous. Don't worry about that otherwise part. This is just for the mathematical formality, make sure that this function is continuous, so that way we can do definite integral, the area exists on the curve, things like that. So part A is asking for, what is the chance, what is the probability that a phone call lasted between 2 to 3 minutes? Okay, well, that's just asking for, right? That's just A. Okay, that's just asking for. So if we were to demonstrate this visually, okay, we will graph the 1 for e to the negative t of 4. If you use decimal, any sort of graphing calculator, you know, you can graph that at, you know, and it will be something like this here. You'll start somewhere here. It's going to start somewhere there, and it's going to start decreasing. Okay. All right. So we asked to find the area. We asked to find the area from, so this is t, right? And then this is f of t. And so we asked to find the area from 2 to 3 minutes. Right, something like that. Okay, so that area, or this probability, so this is the probability. A random call selected last between 2 to 3 minutes. Okay. So to do that, we just gonna set up the definite integral from 2 to 3 of f of t dt, and then we're gonna go ahead and plug in our f of t function, right? dt. All right, so this is just integrating the e to you know, some constant times variable t there. So I'm gonna go ahead and rewrite this a little bit nicer, so that way you can see what's going on there. All right, so this should help us to see how to integrate this function here. So I pull out the constant, and then I also I also rewrite negative t to the 4 as negative 1/4 times t. All right. So using our antiderivative rule from previous chapter, this is going to become 1/4 as the constant in front stay the same. E to negative 1/4 is going to be the same as that for the antiderivative. Okay, but we need to divide by that constant. Okay. All right, and then we're going to integrate this from 2 to 3. All right. Okay. 1/4 divided by negative 1/4, that's going to give us negative 1. Okay, and then that will be e to negative, let's just do t/4 there. I'm tired of running the negative 1. Okay, so negative t/4. Okay, integrate that from 2 to 3. Excuse me, evaluate that from 2 to 3. Okay, so using the fundamental theorem of calculus, we're going to go ahead and do negative e to negative 3/4 minus e to negative 2/4. Okay, so that's our capital F of, this is f of b, and this is f of a, right? So if we do this correctly, okay, if we do this correctly using our calculator, we should end up getting 0.13 approximately, right? So we say that the probability of a random selected call that lasts between 2 to 3 minutes is around 13%. Okay. All right. Okay. Now moving on to part B is asking for what is the probability that the selected call at random will last 4 minutes or less. Okay, 4 minutes or less. Let's go ahead and do that. 4 minutes or less. So that would be, so part B. Okay, that will be the integral from 0 to 4 f of t dt. Okay, because it's saying 4 minutes or less. So that's just going from 0 to 4 there. Okay, so now we go ahead and plug in the function, and the function was 1/4 e to negative t to the 4th, 1/4 e to negative t to the 4th dt. Okay, we've already integrate this part here. We already found the antiderivative from the previous part A. So I'm going to go ahead and just write that, or skip that step, negative e to negative t/4, evaluate from 0 to 4. Okay. So how are we going to do this here? We're going to go ahead and plug the 4 into the t, and then plug the 0 to t and subtract those difference. Okay. All right. So we're going to have e to negative 4/4, okay, minus negative e to negative 0/4. Okay, so that's negative e to the negative 1 minus this is going to be a negative 1. The e to the 0 is going to be 1, and negative is going to be just negative 1 there. So we have negative e to negative 1 plus 1. Use a calculator. Let's see what that turned out to be here. Negative 1/e. All right, and then plus 1. So about 63% there. Okay, so that's the answer for part A. Okay, there is one more part C I didn't include here, but I'm gonna go ahead and discuss that in the next video. Okay, there's another part I want to go over here, and that part is asking for, let's see here. That part is asking for, actually, you know what? I will introduce that in the next video. I don't want to just keep you long in this video here. So